Okay, welcome back. Today we're going to start the second chapter, which is about the lithosphere. Now, in this chapter, we'll talk about the differentiation of Earth. As for the other planets, each planet underwent differentiation من بعد the formation of the solar system, of course. من بعدها we'll see the internal structure, the different theories about the continental drift, the plate tectonics, بعض منكم يمكن سامع عنها, and we will talk about the boundaries between tectonic plates اللي هو راح يوصلنا ل the natural hazards اللي هن earthquakes and volcanoes, ومننهي بالروك سايكل. سو بذكر هير برجع بذكركم انه البلاك سلايدز هن سلايدز مش موجودين عندكم. So as an introduction بدنا نقولكم انه all of the Earth's layers have an impact on human life in some way. Some of them are obvious وبتعرفوهم, like volcanic eruptions, earthquakes. You know that these events come from the interior of the planet, but other effects are not so obvious. And for example, an important example is the magnetic field that protects our planet from harmful energy from outer space اللي هن cosmic rays and solar winds. حكينا عنهم بالشابتر الماضي. This magnetic field is due to the composition of the interior of our planet. Now, our planet radius تبعولها around 6,000 kilometers, but of course no one will ever be able to dig a hole of 6,000 kilometers deep. So بدنا نحط براسنا انه كتير من الاشياء المعلومات اللي رح نشوفها هون اول شيء هي عم تتغير وعم تعمل evolution, and it is based on indirect evidences about them. Okay, and nowadays أكيد كتير هالمعلومات تعتمد على computational model. What is certain is that the processes occurring inside Earth are shaping the face of our planet. So by studying how the Earth formed and studying the processes that constantly shape the layers of Earth, scientists are discovering more and more about our planet, but there is much more to discover. Okay, one example هو بيسألوا كتير كمان هيدا السؤال. Do we know مثلا exactly when a volcano will erupt, or how violently an earthquake will shake? هودي من إذا بدنا الإيشوز الكتير مهمة اللي عم ينشغل عليها, because human lives are at stake. The survival of humans on Earth depend on knowing more about these events and trying to avoid much damage by predicting what will happen. Now, the age of the Earth is a key number, 4.56 billion years ago. It's one of the heaviest inner planets. So in the beginning, it was a giant ball of hot, melted mixed rocks that were unsorted and unorganized. Remember that this primitive Earth had no breathable air, no life, no oceans, and none of the landscapes that you know. Okay, but with time, the Earth evolved. Around the planet, the atmosphere formed, the water cooled and condensed into the ocean, and inside the planet, also the rocks began to cool down and settle into more organized layers. Now, these layers عملوا settling according to what? According to density. The densest and heaviest rocks sank at the center, and the less dense floated on the surface. So, over hundreds of millions of years, the planet hardened and took its shape, differentiating itself into three main layers: the core, which is 17% by volume, but much more by mass; the mantle, 81% of the volume, and the crust, which is the smallest volume, 2%. Now, the Earth's layers can be imagined as a hard-boiled egg layers. You have the shell that is thin and brittle and cracks easily, the white part, which is thick and squishy, and the yolk, which is a solid and tightly packed ball. One of the most important tools that scientists use to know more about the interior layers of our planet is seismic waves. Each time we are recording an earthquake or a volcanic eruption, we know more about the internal structure of the Earth. Okay, seismic waves هن one of the most important tools used by scientists to know more about the interior of a planet. We'll see them later on, but the principle is that waves change velocity when passing from material to another material. And this is what indicates that we are passing from one composition to another composition. This is what defined the three main layers. It has been noticed that there are sudden changes of speed and direction that we call discontinuities. Now, there are three important discontinuities. The Mohorovic discontinuity, also called MOHO, which separates the crust from the mantle. The Gutenberg discontinuity between the mantle and the core, and the Lehman discontinuity between the inner core and the outer core. So this is the internal structure of Earth. We have some key numbers will be repeated here in the table. So هون بس رح ناخد إذا بدنا خليكم خدوا بس هالستركتشر هذه خلوها تكون براسكم. So you have the crust here at the top, you have the upper mantle, the lower mantle, the external core, the internal core, and all of them make 6,371 kilometers, which is the radius of Earth, key number. Now, we also can see the discontinuities between crust and mantle, between mantle and core, between inner core and outer core. هلا بالنسبة الأرقام إذا بدنا أكيد هون محطوطين بشكل أفضل وأسهل لتتذكروهم يعني. أوكي هلأ هون بس بدي أذكر بشغلة. You have here the thickness إذا بدنا محطوطة بهول arrows, and you have here the depth. هلأ depth مجموعة، يعني مثلا هون نحن 5155 هي the depth at the beginning of the outer core. Okay, so عنا أرقام الدبث here وعنا أرقام الثيكنس. بس إذا رحنا على التيبل هون بصير كتير سهل علينا أسهل علينا يعني هود الأرقام هن الدبث والثيكنس. الدبث هي بس نجمع كذا thickness إذا بدنا لنوصل للشي اللي بدنا نعرف على أي عمق موجود. Okay, so you can see here we have the crust, the upper mantle, lower mantle, outer core, and inner core. We have the main composition, which is basalt and granites for the crust. Now the mantle is rich in iron and magnesium, and the core is mainly iron and iron alloys. Now بالنسبة للthickness هلا رجعنا لها. The crust can be up to 70 kilometers. Up to لأنه it is not uniform in thickness ورح نحكي عنها in details later. Okay, بس الماكسيموم تبعولها 70 kilometers. Now the upper mantle 600 kilometers including the transition zone. هلا transition zone حطيت including transition zone لأنه ببعض المراجع بيكون مش including، ساعتها بحطوه مع lower mantle. transition zone هي تقريبا 200 kilometers بتفصل بين الupper mantle والlower mantle. There the crystalline structure changes in important ways and rock become much more dense. Now, the transition zone prevents large exchanges of material between the upper and the lower mantle. The lower mantle نعتبره 200,000 kilometers thickness تبعوله. The outer core 2,200 and the inner core 1,200. So put this way بفتكر إنه الأرقام أسهل علينا من بالفيجر اللي قبله. Okay. Now إذا بدي أعرف which depth ببلش الinner core بجمع 70 و600 و2200 و2200 بعرف هون وين بتكون depth. Okay. So 70, 600, 2200, 2200, 1200. Okay. Now بالنسبة للدنسيتي in gram per cubic centimeter بالchapter اللي قبله شفنا أنه the average density of earth هي تقريبا 5 but we need to know that it's not homogeneous. قلنا أنه the denser material come down to the core وهذا الشيء اللي شايفينه هون بين الكراست اللي هي around 2.2 بتزيد it's increasing حتى نوصل لتقريبا 13 in the inner core. ما حطينا density لكل واحد بس you need to know إنه هو it evolves من 2 at the surface لتقريبا 13 هذه 2 to 3 تقريبا لتقريبا 13 at the core. now بالنسبة للage بتلاحظوا إنه كل layers they have the same age around 4 billion years except the crust. The crust عندها range. We have young crust and old crust من 100 مليون ل 4 billion year. اوكي هلا رح نحكي عنها بالتفصيل وتفهموا ليش هيدي مختلفة بس هو كلهم نفس الشيء. Now بالنسبة للphysical state they differ. We have a solid crust هيدي أكيد كلكم تعرفوها. Now the upper mantle is semi-liquid. The lower mantle is more solid than the upper mantle. The outer core is molten metal and the inner core is solid metal. بالنسبة للtemperature نعتبر the average temperature of the surface of Earth is 15 degrees Celsius وإنها بتزيد لحتى توصل ل around 5,000 at the center of the planet. The crust is a non-uniform layer. التايتل بحد ذاته is an information. Okay, the crust is a non-uniform layer. بكذا شغلة non-uniform بالcomposition بالthickness بالage هلأ بنشوف كيف. We have two types of crust, the oceanic crust and the continental crust. You can see على figure here, you can see a representation of the oceanic crust here and of the continental crust. Just by looking at them and comparing them بالصورة for those who أكثر visual بالنسبة للinformation, you can clearly see the difference in thickness. Okay, the oceanic crust is a thin layer, 5 to 12 kilometers, بينما the continental crust is 20 to 70 kilometers. هلا you can also see يعني بتختاروا إذا عبالكم تدرسوها هون you can add a few notes وتاخدوا على الجرافيك مش على التابل. اوكي هلا بالنسبة للدنسيتي average density للcontinental crust هي 2.7 to 3 بينما الأوشيانيك crust هي over 3 grams per cubic centimeter 3.2 الافريج. اوكي فاذا الدنسر crust بالنسبه للاوشيانيك crust Now بالنسبة للcomposition in oceanic crust we have it consists of sediments بأول layer. Okay, it's a layer of sediments, and underneath we'll have mostly basalt. Basalt is a type of rock that mainly consists that mainly compose the oceanic crust. Now continental crust is granitic rocks اللي هن rich in silicon and aluminium. That's why we call it sial. You can write here sial. Okay? While the oceanic crust is rich in silicon but also magnesium. That's why we call it sima. Now, concerning age, the oceanic crust is considered as the younger layer compared to the continental crust because the oceanic crust ورح نحكي عنه later on هذا الموضوع. The oceanic crust is continuously renewed. Okay, it is continuously formed and destroyed. شكل إنه هذا cycle of formation and destruction does not allow an oceanic crust to get older. رح نشوفها later بالديتيل. You can also see here the MOHO discontinuity. وهون لاحظوا انه بما انه الموهو discontinuity separates the crust from the mantle فيكم تستنتجوا دغري انه الموهو discontinuity ما عندها homogeneous depth لانه oceanic crust is not deep and you can see here the MOHO discontinuity is plunging under the continental crust which is much deeper. So the depth of the MOHO discontinuity is variable. وبعدنا لهلا trying to understand more about the MOHO discontinuity. There has been trial to drill holes to penetrate the MOHO. يعني إذا بدنا أكثر وحدة صار فيها drilling هي up to 12 kilometers in the Kola Peninsula. But the drilling becomes so expensive. The deeper we get, it becomes very, very expensive. So the project was dropped. Now بالنسبة للليثوسفير تعبير الليثوسفير رح نستعمله كتير especially when we will talk about the tectonic plates. We will say that they are plates of lithosphere. في a difference between the lithosphere and the crust. The lithosphere is 100 kilometers thick تقريبا. It floats above the asthenosphere. It is composed of the crust and a superficial solid part of the upper mantle. Here you can see the lithosphere. فإذا تعبير lithosphere منه مثل continental crust, mantle and core اللي هن إذا بدنا a classification by composition. Now here كلمة lithosphere is not a layer يعني مميزة ب composition معينة عن غيرها. No, it's a mixed layer إذا بدنا بين اثنين layers. يعني هي continental crust plus شقفة صغيرة من upper mantle. Okay, it floats on the plastic asthenosphere here. And the asthenosphere is hot. عم نحكي عن تقريبا 1500 degree Celsius صرنا هون. It's the most plastic section of the upper mantle. It behaves like a very thick liquid. And here على هيدا layer رح تتحرك the plates and create the movements of the tectonic plates. Okay? So هون فينا نشوف مثل ما قلنا continental crust, the sedimentary deposit, an oceanic crust, ومنشوف إنه lithosphere هي تقريبا 100 kilometers. We will see later also that it's composed of rigid plates in motion that slide on the asthenosphere. The origin of the movement of these plates is a convection movement in the Earth's mantle. كمان هيدا رح نوسعه بعد شوي. بالبارت اللي رح تكون the theory of plate tectonics. وهيدي الثيوري بتعمل إذا بدنا بتشرح لنا earthquakes, volcanic eruptions, the formation of the earth's crust, formation of mountain ranges. But before we start with this theory, we will start by another theory that had been proposed before, which is the continental drift.